All right, so we last left off in the 120s, so I'm going to get started with number 132. We're being asked to write the equation of a circle with a center at negative 16, 1 and a radius of 3. Remember, the equation for a circle is x minus h squared plus y minus k squared equals r squared. And so where this is h comma k, but it's opposite your intuition inside parentheses. So this thing here is simply, it's just x minus negative 16 becomes x plus 16 squared plus y minus 1 squared equals, let's see, in this case, 3 squared is going to be 9. And you're done. Nothing to it. Okay? Where this stuff starts to get a little more tricky is in problems like number 136, where they give you the vertices of an ellipse. So let's say negative 5, 8 and negative 15, 8, and they give you the foci, and that is at negative 6, 8 and negative 14, 8. Okay, what is the first thing that I always recommend all students do when faced with a problem like writing the equation of a conic section? What do I always recommend people do? Alan, what do you think? Graph it. Just draw it. And not even graph it well. You just draw a picture of it. So if you don't draw a picture of it, I start calling you Tim Westwood. All right, so negative 5, 8. That's about right here and right here. Let me write this down. Negative 5, 8. Negative 15, 8 is way out here. So this is negative 15, 8. My foci are at negative 6, 8, so that's going to be about right here. And then negative 14, 8 is about right here. Who can raise their hand and tell us what type of ellipse does this have to be? What type of ellipse does this have to be? Based on what you see from the foci and the axes, what do you think, Skylar? It's got to be a horizontal ellipse, right? Got to be a horizontal ellipse. Okay, so now what we have to do is we have to find the center of this thing. I have a major axis, a major vertex here and a major vertex here. How would I find the center of those 2 points? What would I use to find the center of those 2 points? What do you think? Jake, you got an idea? Or cut the distance of the vertices in half. Either way, use what's called the midpoint formula. And it's just the average of the 2 points. So it's going to be negative 5 plus negative 15 over 2, comma, 8 plus 8 over 2. So that is negative 20. So it looks like our center is negative 10, comma, let's see here, 8. I lost track of what I was doing there. Okay, negative 10, 8, so I'm going to go and draw that center piece. So it's going to be about right here. Right? Kind of a funny looking guy right there, right? Okay. All right, so now that we have the center, do we have enough information to write at least half of the ellipse's equation? Alan, what does that look like? What does an ellipse always equal? 1. Okay, now it's just figuring out what goes underneath here. Okay, let me go ahead and draw this again. This up here is negative 10, 8. So what I need is I need the distance from negative 10, 8 to negative 5, 8. What is the distance between negative 10, 8 and negative 5, 8? Just count. It's just counting. Mark? It's 5. Now, because these are along the major axis, what letter have I just found? A. So if 5 is A, then A squared is 25. And which one of these values gets the 25? Under X. Brother, why is it under X? Because it's good job, brother, because it's horizontal. All right? Very good. Okay, so now I'm going to go and switch colors here. Let's go and switch to some relish. Okay. This here, this focus, the coordinates are -6, 8. So what is the distance between the center, which is -10, 8, and the focus, -6, 8? What is that distance right there? -10 to -6. What is that distance? What do you think, Nikita? It's 4. Now, Nikita, do you know what letter is represented by that distance? It's C. So C equals 4. So if C equals 4, then C squared equals 16. And we pump that into CAB formula. So it'll be C squared equals A squared minus B squared. Subtract 25 from both sides. So you get -9 equals -B squared. So you get B squared equals 9. Now don't worry about saying B equals 3, because the fact that it's B squared equals 9 means that it goes straight into there. And that's all you got. If you guys didn't understand that, check out the period 2 video. I did the others. I did the other 3. Okay, so let's move back to doing what we were doing. Okay, so let's I want everyone to look at, because I can't draw this picture on the page, so I want everyone to look at number 139. Oh, darn it. Wrong color. Because I'm going to ask you to reference number 139 from time to time. Alan, how are you? Good? Okay. Who can raise their hand and tell us what is the center of that hyperbola? Just look at your packet, center of the hyperbola. Danny? -1, 2. And since it's a side-to-side hyperbola, which one's going to come first, x or y? Mark? X. So who can raise their hand and tell us what is the equation of that hyperbola, at least the top half of it? What's the top half of that equation? Mark? Squared. Plus in the middle? Minus in the middle, right? And Mark, all that equals 1. Okay. Getting the equation of a hyperbola is actually extremely easy. So I have the center being 1, 2. What are those dotted lines that the hyperbola doesn't cross? What do we call those again? Asymptotes, right? And the asymptotes had a slope, yeah? And that slope was y over x, yeah? All right, so let's go ahead and see if we can figure something out here. I want everyone to look at the top right corner of the box that is drawn on your number 139. So the top right. Can someone raise their hand and give me what are the coordinates of that top right corner box? The top right corner of that box. What is it? Yael, what are the coordinates there? The top right of that box.
4, 7.
No. Mark. 1, 4. Everyone see where 1, 4 came from? All right, the box that is encompassing the asymptotes. All right. Okay, so now what I'm going to do is I'm going to use these points here to find the slope. So that's going to be 4 minus 2 over 1 minus -1. And that is 2 over 2, which is 1 over 1. Remember, it's plus or minus. Now, because a hyperbola has the slope y over x, this becomes a 1, this becomes a 1, and you're done. In a hyperbola, it's actually very, very easy. All right, let's do another one, because I feel like that, the top right corner of the box, I looked at it. I looked at the picture. Okay, why don't we do number 144? Okay, let's see here. Number 144. Mr. Castle, can you tell us what is the center of that hyperbola? It is 1, negative 1. So, based on the fact that it is a side-to-side hyperbola, who can raise their hand and start us off on writing the top half of that equation? Kylie, what is it?
X minus 1 squared minus y plus 1 squared equals 1.
Sounds good to me. Okay. I need to find another point at which that is very, very well known. Can anyone raise their hand and tell us what is a point that is very, very well known? Look at the box that houses the asymptotes. Alan, what do you think? 5, 2. That is correct. If you look at your graphs, 5, 2, that's a clear point of intersection, right? So now I find the slopes of the asymptote, so that is 2 minus negative 1 over 5 minus 1. That is 3 over 4. Okay, this one's a little more concrete. 3 corresponds to which letter? Brother. Y, and 4 is X. So, brother, what is going to go underneath the Y plus 1? Anyone know what's going to go underneath that Y plus 1? 9, yeah. Because 3 squared, right? So, brother, based on that, what's going to go underneath the X? 16. You're done. I like these problems. They're cool. All right. Oopsie. Okay, we have done quite a few parabolas in the period 2 lecture, so I'll go ahead and I'll do one. Okay, number 152. It says focus 5, 2, and then the directrix is x equals 13. All right, so first thing you do, Tim Westwood, is do what? Draw a picture. All my Tim Westwoods in there. Tim Westwood? I have no idea. But that's just what I call people who don't draw pictures. Focus 5, 2. 5 and 2. That is my focus right there. My directrix is x equals 13. So that is a vertical line all the way out here. Now, let's use some sense. What is the only direction that this parabola is allowed to open? I know brother knows the answer. I know Alan knows the answer. I know Ryan and Jake know the answer. Let's see here. Skylar's got it. Noah, do you know which way this thing can open? Which way? Got to be to the left, right? Got to be to the left. So it's going to do that. Yes? Do we agree? Okay. So now, I don't like that. I like that more. Okay. So now what I'm going to do is I'm going to identify these coordinates are 5, 2. Now, I need to figure out a point right here. Would it make sense that this is 13, 2? That the point I just drew, I'm going to change over to ketchup here. Would it make sense that that point is 13 over 13, 2? Right, because this is 5, 2, 13, 2. So what is the relationship between the vertex and the focus and the directrix? What is that relationship? How are they located? Ryan, what do you think? They're equidistant from the vertex, which, in other words, the vertex is in the middle of them. So I can use midpoint formula to figure out the coordinates of the vertex. So that's 5 plus 13 over 2, 2 plus 2 over 2. So that is 2 on the y. This is 18, so 9, 2. Now, be careful. We can begin writing the equation of the parabola. But be careful with this. Is this a y equals parabola, or is it an x equals parabola? Brother, it's x equals parabola. Good. And it's going to be a, parentheses, what's going to go on the inside? It's y minus what? Jake? Yeah, y minus 2 squared plus what, Jake? 9. Now, what's the problem with a right now? Brother, it's got to be negative. Why? Because it's opening to the left. All right. Now we have to solve for a. Here's how we solve for a. Let me switch over to relish here. Okay, so this here is 9 comma 2. Sorry for the small writing. I need the distance between 9 2 and 5 2. What is that distance? What is that? I'm gonna do it down here. What is the distance between 9 2 and 5 2? Yael, what's that distance? Started at 5. We're going to advance to 9. 4. Now, which letter does 4 correspond to? What is 4? What represents the number 4? Jake? C. Now, finding the distance and finding the a term in a parabola is going to be different than CAB formula. We use C equals 1 over 4a, which means I can substitute this 4 in and get 4 equals 1 over 4a. Cross multiply, I get 16a equals 1, a equals 1 over 16, which means my final equation is x equals negative 1/16 y minus 2 squared plus 9. Duh? All right. Let's do. Okay, everybody, going quiet down, please. All right, so this is similar to the one that we were just doing. So what I'm going to do is I'm going to do the same thing we did last time. I'm going to go ahead and I'm going to get y by itself this time. So I'm going to say y equals negative x plus 4. All right, and that was done by subtracting x and adding 4 to both sides. And from here, I'm going to go and just substitute everything in, just like the last problem. So it's going to look like 2x squared minus negative x plus 4 squared minus 18x minus negative x plus 4 plus 20 equals 0. So far, so good? We just plugged everything in. Okay, now I'm going to do arithmetic just like last time. So it's going to be 2x squared minus, this quantity is going to be x squared negative 4x, so negative 8x plus 16 minus 8x. Let's see, I'm going to go and distribute that. That's going to be plus x minus 4 plus 20. When I distribute this negative, it's going to be negative x squared plus 8x minus 16. That's gone. Okay, so let's go ahead and, oops, and that thing is now gone too. So 2x squared minus x squared is x squared. Those are gone. Alan, how you doing? 8x minus 18x plus x, so that looks like negative 9x. Negative 16 minus 4, oh wow, looks like those are all going to go away. Right, negative 16 minus 4 is negative 20. Negative 20 plus 20 is 0. Okay, easy problem. What are my solutions, Jake? Factor out an x. I get x minus 9. So x equals what? 0, positive 9. Very good. Okay, I'm going to rewrite the bottom equation, which was x plus y minus 4 equals 0. Remember, we converted that into y equals negative x plus 4. Duh? Okay, so now let's go ahead and solve for y. Move this thing over just slightly. So I get y equals negative 0 plus 4. Well, that's gone. Y equals 4. So what that means is that when I plug 0 into the bottom equation for x, my result is 4. That's the first solution. So go and box that. You're done with it. We're going to try again. Y equals negative 9 plus 4. Whoops. So negative 9 plus 4 is y equals negative 5. That means that when I plug in 9 as my x, my output value is -5. And that is the other solution. Kylie, does that make a little more sense than the last problem? Whoa. All right, so let's take a look at the last couple problems here. It says, write the quadratic equation that has the given zeros. Let's go ahead and do numbers 162, 164, and 166. Oops. Okay, given the roots. Now, this is something that you guys need to get very good at, because in Chapter 8, which is when we get back from break, this is going to come up a lot, this idea of being able to write a polynomial function. What you do is you set x to subtract whatever roots they give you. From here, I'm going to get rid of this fraction by multiplying by 8. So what I really have is x minus 2 times 8x minus 5 equals 0. Go ahead and FOIL that out. That's 8x squared minus 5 minus 16 is minus 21x plus 10 equals 0. And you're done. Is that pretty easy? I think it's pretty simple. Okay, 164. The roots are -4, -2/3. Okay. Anyone want to dare set this one up? Yael. -2/3, right?
Yeah.
Okay, so let's just go and simplify this. This is x plus 4, that's a no-brainer. And this is x plus 2/3. How do I kill off that fraction right there? Leanne? Multiply by 3. So what I really have is 3x plus 2, x plus 4. Okay, so now I'm going to go ahead and multiply this in. This is 3x squared plus 2 plus 12 plus 14x plus 8 equals 0. And that's what you get. It gets harder with number 166. Sure, why not? Remember, this is the prerequisite for the next math class, and in the next math class, you guys encounter stuff like this a lot. No imaginary numbers, though. Calculus studies rate of change, and as of in the AB class, you don't do rates of change of imaginary numbers. Okay, everybody, go and quiet down, please. So what you have to do here is you set it up exactly the same way. It's still x minus one of the roots, -2 plus 5i over 4. Multiplied by x minus -2 minus 5i over 4. Because we have fractions in both, I'm going to multiply everything by 4. So what I end up with is 4x minus -2 plus 5i times 4x minus -2 minus 5i. Now, at this point, you might be tempted to distribute that negative. I would encourage you not to. That's my own personal preference. It just creates really messy things. If you have to do a triple FOIL, it can get really nasty. So let's go ahead and keep it unnasty by FOILing normally. That's 16x squared. This here, a negative thing times a positive thing gives me a negative thing. Well, that thing happens to be 4x times this thing. It happens yet again. I got a positive 4x times a negative version of this, so it's going to be negative 4x, parentheses, -2 plus 5i. Now, what do you normally expect your i's to do? They should cancel each other out, right? I've got a negative thing times a negative thing, that gives me a positive thing. And that thing happens to be negative 2 plus 5i times negative 2 minus 5i. So let's go ahead and clean this up. 16x squared, nothing messes with that. Negative 4x times negative 2 is positive 8x, positive 20xi, positive 8x, negative 20xi, 4, so this is 4, es un conjugado, so I only need to multiply the inner and the outer, minus 25i squared. Hey, what's I squared again? Negative 1. So negative 25 times negative 1 is positive 25, so that's plus 29. What did we expect the i's to do? And do they? Positive 20, negative 20 go away. 8x and 8x becomes 16x. Tack on the 29, tack on the 16x squared, and you're done, right? No! Equals 0. Now you're done. Okay? Good job, you guys.